Moving on to the next page, we have a new ADT called the discussion ADT, and it contains three things: the name of the TA running the section, the time it starts given as an integer, and a list of students enrolled in the section. And along with it, it comes with three selectors and one constructor. So the constructor takes in the TA, the time, the students, and then the three selectors will give the TA, the time, and the students respectively. So these TAs have decided to reveal the implementation of the ADT that represents discussions. And so these are actually the functions. And so the constructor is basically it takes in the TA, the time, the students, and then returns the list of the name, the time, and the students. Well, actually this should be, TA. But basically the TA is just the name of the TA, so right, so name and TA just mean the same thing. And then the get TA will return the first element, which should be the TA's name, and the get time will be the second element, and then the get student is the third element. Alright, so moving on to the question about this ADT. We're supposed to implement add student, which takes in the discussion section and a string representing a student's name, and returns a new discussion with the new student added to the roster. So the list of students for the new discussion should be a new list. And a reminder to use the constructor and selectors. Okay, so first we gotta get the list of students. So what we can do is call the selector, and so we're going to get, well, first I'm going to say new students because I'm going to add and get the students at the same time. So new students equals get students. And then I'm going to tack on this new student. And it's totally fine that we know this is a list because that doesn't break the abstraction barrier in this case. The main idea here is that the whole discussion is abstracted away, not the way the students are represented. Because if you think about the many ways that students can be represented, there's not that many ways to put something in some kind of sequence. It's usually going to be a list. So there's really not much surprise there. But the main idea here in this problem is that this discussion can be represented in different ways. Okay, and we'll see that in the next problem. So we have this new students list, and now we just need to make pass this new students list into a new discussion. So first we're going to get the TA and the time for the old discussion. So TA equals get TA of disk, and then similarly we have the time, get time of disk, and then we're going to make a new discussion and return it. So make disk of TA, time, and new students. Okay, so that's it for this problem. But I do want to note that if you were to break the abstraction barrier, what you would most likely do is, instead of get students over here, you could say something like disk of 2, because we know that in the previous page we saw that the students is going to be the third element in the list, which is also the second index, or index 2. And so if you said disk of 2, this would give you the students list, but this would break the abstraction barrier. So this is not a good example, but I just want to illustrate to you how the abstraction barrier could be violated in this case. Okay. Alright, So in our next problem, we ask ourselves, if a student makes changes to the discussion data abstraction, and the change here, notice, is that we're using a dictionary instead of list, because in the previous page we saw that it was a list, highlighted over here, but now we're dealing with a dictionary that represents the discussion. So the question is, with these new changes, would our code in the previous question still work? And would the code before removing abstraction violations still work? Okay, so this is basically asking us, did we follow the abstraction correctly? And with this code that we wrote here, not including the red stuff, this will still work, and it still works. Okay, but if you were to write discussion to, like over here, with this red part, it would not work because it's assuming that the students is in a list and it's the third element, and that's not true anymore when you change the discussion to be represented by a dictionary instead of list. So this notation won't work anymore because it will give you like some kind of syntax error, like you're trying to treat it as a list, but it's actually a dictionary now. So the code we wrote in black would work just fine after the change, but the red stuff would not work if you wrote that. Okay, so that's the importance of not violating the abstraction barrier, because if we make some kind of change, then we don't have to change our other code, and we can rely on it to still be correct even after changing it from a list to a dictionary. And so that is one of the great things about having abstraction, is that if you make a change, then you don't have to change it so many other places as well. Okay, and for our extra question, we have a question, or we're asked to write a function that takes in a sequence S and a function fn and returns a dictionary. So the values of the dictionary are lists of elements from S, and each element E in a list should be constructed such that the function called on E is the same for all elements in that list. And finally, the key for each value should be the value of the function called on E. So I really like to look at the doc test whenever I do any kind of code writing questions. It's very helpful. And in this example, we see that we have a function that will take in, actually let me highlight this, that takes in a P and does P florative 10. So it just divides the input by 10 and then truncates it. So what I mean by truncate is that it has no decimal. Okay, so we can see here that 12 and 4 both get put into a list that 1 is mapped to, and 2 is mapped to a list of 23, and 4 is mapped into a list of 45. So you can see here that it's applying the function to the numbers in the list, and the value after calling the function is going to be the key. And if there are two elements that have the same value after calling the function, then they get put into a list where the key is that value. Okay, and you can also see an example here. So remember, range of -3 to 4 is going to give you -3 to -3 to 3, but not inclusive of 4, because range is not inclusive of the end. And then the function here is a little bit different. It's going to square it. So what we're looking for is basically grouping the elements that when squared, they equal the same thing. This is usually just going to be the positive and negative pairs. So 0 is mapped to 0, 1 is mapped to -1 and 1, because they're both 1 when you square them, whereas mapped to -2 and 2, and likewise we have 9 mapped to -3 and 3. Okay, so here's how we want to do this. First off, we want to start with by making a new dictionary. So I'll just say it's called grouped, and it's an empty dictionary. And then we're going to iterate through the sequence. For x and s, we need to figure out which key it would be mapped to. And remember that the key is always going to be the function applied to that element. So the key is going to be fn applied of x. And then we're going to check if that key is already in our dictionary. Because if it is, that means we know there's already a list that it's mapped to. And we can just add it to that list. But if it's not already in the list, if it's not already a key in the dictionary, then we need to make that list and create the mapping. So if key in grouped, then we can do grouped key dot append x. So what this is going to do is take that list that the key is mapped to and then append x to it. So now we have, like let's say in the first example over here, we have, at some point we have 1 mapped to 12, right? And then when we see 14, we know that 14 floor of 10 is also 1. So we're going to tack on 14 so that it becomes 12, 14. Okay, so that's what we're doing in this case. Now, if this if statement returns false, so it's not true, then we want to know, we know that we want to add this new pairing. So we're going to set grouped of key to be a list containing that value. Or sorry, not the value, the element. Okay, so element is going to go in its list, and that becomes the value that the key is mapped to. And that's really all there is, because that's the two cases. But now we want to return the dictionary. And that is it for this code. So that was the entire discussion 6, including the extra